are in for a treat. I'd like to introduce our speaker tonight, Dr. Mike Adler, who worked for General Electric from 1971 till he retired in 2002. At GE, he headed a laboratory of 150 people to develop power electronics, control systems, high density electronic assemblies. He was Senior Technical Director of Mechanical Technology, Inc., which is a MTI, not sure what that means, from 2000 to 2005, and an adjunct professor at RPL in Troy, New York. Mike did graduate from MIT finally with a PhD in electrical engineering in 1971. It was, I think, one of 3 or 4 PhDs that Mike accumulated while he was at MIT. In solid state physics, he was involved in the development of new generation of power semiconductors and published over 100 papers, and was elected the IEE, that's the International Electrical Engineering Group, but he's a fellow of that for his work in power devices, and he was elected president of that in 2003. Now, since retirement, we've been blessed with Mike and his hobbies, which include skiing, hiking, climbing, travel, photography, and astronomy. And the key word in all of that is photography. He's going to be discussing today an area with incredible vistas and views, and I'm sure Mike has turned those into spectacular imagery that you'll be looking at and he'll be discussing. In the last few years, as a small side note, he became interested in the science of astronomy. He has now moved full-time to Jackson so he can really keep track of his rather advanced observatory that he does a lot of astrophotography. And he's given a number of lectures, both in New York and in Jackson Hole. So we're delighted tonight to have Mike Adler, and I encourage you to sit back and enjoy. If you have questions as we go along, like Brent said, put them in the chat and we'll get to them at the end. So without further ado, I'm going to turn it over to Mike to take us to Canada.
Okay, John. Well, thank you very much for that nice introduction. Yeah, it's the Institute of Electrical and Electronic Engineers, by the way. And,
there we go. Thank you.
It happens to be the largest technical society in the world, with about 500,000 members. But
whoa.
Anyway, I'm going to start sharing my screen and get on with the main event here. And we're going to, okay, come on. Okay, there we go. I got to move myself off to the side so it doesn't block my view. Okay, so this is a picture of Virginia and I on our 50th anniversary in island of Newfoundland in the Gros Morne Park, and I'll talk some more about that in a bit. So the talk is going to be about the geology of Eastern Canada and the United States, although truth in advertising is going to be mostly about Eastern Canada, but some of it is very much related, and that I'm going to talk about that at the introduction of the talk. Then we're going to switch to part of Eastern Canada, but the very northern part called Labrador. It's actually part of the Labrador, Newfoundland province, and specifically a trip I took in 1973 by kayak to northern Labrador, where we did a few things like climb the highest peak in Canada east of the Rockies for the first time as a first ascent. Then we're going to talk about geology of Newfoundland, the island part of the province. And we made 18 trips there from 77 to 2005. And so it's going to be a combination of geology as well as scenery and what have you. And we're going to end with a very little bit about Saint Pierre, Miquelon, which actually belongs to France. It's their a consolation prize for having lost the rest of North America, but the Brits don't have anything. So the French still are holding on to Saint-Pierre. Okay, so the whole story begins with the Canadian Shield. The Canadian Shield is shown up here. The part that's above ground is huge. It goes all the way up into Greenland. It's the largest Archean body in the world. Going back to 2.5 billion years, and some rock in it as far back as 4 billion years. It's mostly metamorphic rock with gneiss and some intrusive rocks such as granite. It's now a peneplain, which means mostly a plain, but it once had mountains as high as 40,000 feet, 39,000 feet. In addition to being above ground in Canada, it forms the basement rocks of much of the United States, shown here. And you can see this cross section going from A1 to A. And you see where the Grand Canyon is. It dips into the Canadian Shield for sure. Okay, so the real story begins with a couple of continental collisions and several cycles of plate tectonics. First with the assembly of the supercontinent Rodinia about a billion years ago with what's called the Grenfell orogeny that essentially merged North America and South America. Then we're talking about, we jump ahead a couple of 500 million years, and the continent breaks up and we form an ocean called the Iapetus Ocean, which lies between Laurentia, essentially North America, Amazonia, essentially South America, Baltica and Siberia, Europe. And that sets the stage. Then what happens is the Iapetus Ocean doesn't last very long, and it starts closing and actually completely closes by about 435 million years. And that's where things get very interesting. Because it's that collision and sets the stage for the formation of the eastern United States and well, what is now the eastern United States and eastern Canada. And it's called the tectonic orogeny. So the next chart shows this in a little more detail. It's very interesting to note that this orogeny actually spans 10,000 kilometers from north all the way up to in the very northern area of the continent of the world, all the way down to the tippy tip of United States and the African plate. And activity occurs on both sides of the Atlantic. And we'll talk a little bit about that. But the tectonic orogeny, what we're going to focus on our side of the Atlantic, begins in three phases. One is the closure of the ocean, the Iapetus Ocean. And then a couple of events. One's called the Acadian orogeny, about 400 million years ago. And then there's an Appalachian orogeny at about 300 million years ago. And what this does is that together they are responsible for the buckling and the thrusting of previously deposited sediments from the Iapetus Ocean. And the Appalachian Mountains, the present day Appalachian Mountains, are the eroded remnants of all of these events. And those mountains, well, we'll talk some more about that. So the cartoons here kind of just show what's going on. Here we have the Appalachian Mountains first forming with the docking of the Acadian of Avalonia and the Acadian orogeny, further squeezing when Pangea is completely formed by the Alleghenian, or otherwise known as the Appalachian orogeny. Then around less than 200 million years ago, the Atlantic opens back up, and we get some very interesting things happening where parts of the European and African continents stick on North America, and parts of North America stick on Europe. And we'll talk some more about that. But here's what we now are left with. In this particular case, we're focusing mainly on Eastern Canada, but we have the island of Newfoundland up here, and the Gaspé Peninsula and down here. And these various regions all have very interesting parts of their origin. And I'll talk some more about that in a second. So just to quickly summarize, so there's several cycles of what they call Wilson cycles, which is basically several cycles of plate tectonics with Rodinia forming, breaking up, Pangea forming, breaking up, and then the Atlantic forming. So there are several cycles of continents colliding and opening back up. So now jumping ahead to the present and trying to and looking at both the Eastern Canada and the United States, we see some common areas. This green area that's up here, a thin green area that's up here, and the area down here called the Blue Ridge Belt are basically the same rock. And it's the same as what's known as the Dunnage area, pretty much the same as this rock as well. And it's 400-million-year-old sandstone, shale, and limestone coming from the bottom of the Iapetus Ocean. The gray area down here, and also the gray area up here near Boston, and then all the way up along here, are chunks of essentially that stuck from Europe and Africa and are about 1 billion years or 1,000 million years old. The yellow area, it's called the Gander area. It only exists, well, you can see it up here in Newfoundland and then also in down through Nova Scotia, but it extends all the way into New England. And this is largely, it's a mix, but mostly 400-million-year-old granite that occurred from the Acadian orogeny. And this rock forms the White and the Green Mountains in the United States. It also forms mountains in Newfoundland as well. Now, the coastal plain of the United States, which is down here, is much younger rock, and it's mostly sediments, less than 100 million years ago. And frankly, that's all we're going to talk about as far as the geology of the United States. So we're now going to focus almost totally on Eastern Canada. One more point about the United States, and I'm only going to make 2 points here on this chart, on this map. One is the Appalachian Mountains extend all the way from the Long Range Mountains in Newfoundland down to the Great Smoky Mountains in the United States. Second point is the name. Where did the name come from? Well, it's attributed to I have to get my name out of here, a Spanish explorer named de Vaca in 1528. He came across a town that was transliterated. In other words, it sounded like Appalachian. Anyway, that got eventually morphed into Appalachian. The second thing I want to mention about this chart is the Adirondack Mountains. Now, they were once thought to be part of the Appalachians, but in fact, they are not. So this is an example of a chart that I'm showing, which is not a part of the Appalachian Mountains. The Adirondacks are part of the Laurentian Mountains, essentially a chunk of the Canadian Shield that is above ground in upstate New York. And that's close to our heart because we lived there for something like 40 years. But so just to set the record straight, the Adirondacks are not a part of the Appalachians. They're much older rock, actually. Okay, so now we're going to jump way north, and we're going to talk about geology of Labrador. Now, Labrador is all a part, part of the Canadian Shield. And the last segment of the Canadian Shield, as it's known, was formed about 1.8 billion years ago. But so this is the present day map of the geology of the Labrador Peninsula. Now, Labrador is a part of the Newfoundland province. It's the Newfoundland Labrador province, as it's called. It's the easternmost Canadian province. Probably the most remarkable part of it is that this coastal area is all gneiss. It's of various ages, but this area down here in purple that has letters UN on it, you probably can't read that. But that's rock that's over 4 billion years old, some of the oldest rock in the world. There's also mixes of other of intrusive rocks of various ages. You can see in this red is intrusive rock. There's also some sedimentary rock, metamorphic sedimentary rock in here, and some more intrusive rock down here. So this is just another map of the same, not quite as detailed, but it highlights some of the features of that are relevant in the talk. We've made 2 trips, or I have made 2 trips. Virginia has made 1 trip, but the first trip was in 1973, where 6 of us kayaked from Nain, Labrador, all the way up to the Saglak fjord, and then we hiked into this area, and this. So this was we're going to talk quite a bit about this. This was led by a good friend of mine, unfortunately, who's passed away some years ago, named Chris Gertza. The second trip was one that Virginia and I were on just 2 years later, where we went all the way back up. We met our friend Steve Luttrell, who has this nice 40-foot sailboat. We met him in Nain, and we sailed all the way up to Cape Chidley and then back to Nain. So he sailed all the way from Boston, but we joined him on this, the Labrador section of the trip. So I'm going to now talk about, we're going to talk some more about geology, but we're going to talk about the, in the context of this kayak trip, which was quite a remarkable undertaking. The original, actually go back to the previous chart, the original intent of the kayak trip was to kayak up into this area, get to the Nakvak fjord, and then go across the peninsula to the Angava Bay side. Well, it didn't work out quite that way. What happened was, as soon as we got up here, and this took us about, this is 250 miles, this red line is the track that we followed in our kayaks, 250 miles, over about 9 days. When we got up here and started looking at the water in the river, the Korak River, we found out there wasn't enough water to get us across. And it's probably just as well we never even tried, because that trip has now been done fairly recently with modern kayaks, and we would have never made it. Our Kleppers, which I'll show you the boat, is their fabric covered wooden framed kayaks, would have never survived in that river, even if we had been able to get to the navigable part of it. So what we did instead was we set our sights on climbing. And but by the time we actually got up here and and had done some hiking, most of us were fairly exhausted. We didn't quite have enough food for the hiking part of this. And so we broke up into 2 groups. One group, which I was in with Chris Gertza and another fellow, and we went up and we set our sights on climbing this peak that's now known as Mount Kalbik, but at the time it wasn't named. The other 3 also were trying to do it, but they went on a route further to the west because it was shorter. But as it turned out, it was shorter, but it had the likelihood of being more difficult at the final end. And now, because we didn't have detailed maps at this time, this is 1973. They were detailed in the sense that they were accurate, but the contour interval was 500 feet, and so we didn't have an awful lot of to base on what route would actually work to climb this mountain. Now, this mountain is a mile above the sea level, in which is where we started our climb from. So we went up and tried to climb it on this yellow route. Anyway, we'll talk some more about that in a bit. This is where we left the open part of the ocean in Saglak fjord, and this is a view from a peak that we climbed, just looking out to the open ocean from there. Oh, sorry, wrong direction. So here's a little bit about the geology now. This is a picture of in Saglak fjord. This is this whole layer is a Canadian shield where these rocks are, ancient, mostly 3 billion year or older gneiss. But you can see also the effects of the last stage of the forming of the Canadian shield, these incredible bends and folds where you have the stratified younger rock folded over the older 3 billion and a year old gneiss underneath. And this picture shows it in a little more detail of that one area by itself. So obviously a lot of squeezing and scrunching occurred here. So now a couple of pictures of our kayaking. These are Klepper kayaks. By the way, if anyone is interested in one of these, I still have mine. It has a new outer skin on it, so it's actually in pretty good shape. But this is Steve and Lizzie Luttrell. And on this picture here, if I can get my picture out of it, are the other couple of kayaks. This area here, these are like 3,000 foot cliffs. And so this is the kind of terrain that we were kayaking in once we got up towards the Saglak and Nakvak fjord area. One of the hairy parts of this is that we are on this on the open ocean. And in some cases, without a place to pull in if the weather turned bad. So that was the thing that was hanging over our heads. Fortunately, our weather held very well, and we didn't have any big storms while we were kayaking. This rock, this particular chunk of rock here, is over 4 billion years old, all layered gneiss, as you can see. Some pretty 3 billion year old gneiss here. This shows us what it was like when here's our 3 kayaks lined up. We pulled ashore a couple of times every day for various reasons, including just taking a break. We camped in tents, and when we were on the shore, we would camp, needless to say, close to the boats. But when we started hiking, we were on the tundra, as shown here as well. We supplemented some of our food. We were able to catch fish, quite a bit of it, and this is Arctic char. And we did paddle among icebergs in various times. So some more pictures, again, going back to 1973. This peak both peaks are over 4,000 feet above sea level. This is called Bishop's Mitre, and this is called Brave Mountain over here. We stopped at this Moravian village. It was established by Germans in 1771, but it was abandoned in 1995. And this is 1973, so there was no one living here. We never saw a soul on this entire 5+ week adventure, by the way. We were all alone the entire time. Needless to say, in 1973, we did not have satellite telephones or radios or any way to contact anyone. So we were totally all by ourselves. Just another picture of Hebron and everybody in the group except me, because I'm taking the picture. So this is the day. So what we did was we broke up into these 2 groups, as I mentioned, and we hiked 3 days to get to the general area of where this mountain is. And this is the last day, involving, something like, I don't know, 7 or 8 miles. But it basically, we're following this ridge here up to the skyline, and then along the skyline and to this, what's called the Minaret Ridge right here. And this is the actual summit. You can see it's surrounded by glaciers on all sides. All of this was pretty straightforward until you got to here, and this is where the tricky part was. This ridge on this side, the western side of the ridge, was very difficult. Turned out to be very difficult, and our friends, which actually did approach it, were not able to climb it. It was quite technical. So this is just a picture of from Google Earth showing that ridge that I was just showing you. You can see the mountain is surrounded by glaciers on all sides. This is a map of our route. This has 100-foot contours. We did not have this map on the trip. Ours were 500-foot contours, but it was convenient to plot this route. So our route was this red route, and this is the last part of it that showed in that picture. And this was the yellow route that our friends took to try to climb it from the west side unsuccessfully. This climb has now been done from the west side. In 1997, it was done, but it's treacherous, and the weather up here can be treacherous as well. And in 2003, a couple attempted to climb on this side. The fellow injured himself. The wife and went off for help, and she died of exposure. It's 300 miles over very rough and difficult terrain to get to any help. She never got to any help. She died, and he did eventually as well. So this is can be a very difficult and unfriendly area. So this is my picture of the final area of the ascent. This all goes pretty well, is pretty straightforward until you get to about here. And then you're going up and down these minarets on what's called the Minaret Ridge. I'm not going to read this, but if you can go onto the website, yeah, actually, if you go onto the website, I show a picture of this later on, describes the route a bit, and this just highlights what we did to get there. 250 miles of kayaking, and 25 miles, and then a final 3 miles along that ridge before we got to the technical part of the Minaret Ridge. So this is actually on the summit of Mount d'Iberville, Mount Kalbik. It has two names. I'll describe that in a second. But this is the western ridge that is quite severe and difficult, and that I described has some tragedy associated with it. This left picture is a view from the summit looking towards the ocean, which is off in the distance here. And this is a picture of me down here, down climbing the Minaret Ridge. So you can see it had its own challenges as well, because we are basically staying right on the ridge line, climbing up and down these various minarets to stay on the knife edge. It was exposed on both sides. We didn't have any climbing equipment, so it was all done free form. We just moved very carefully. Needless to say, injury here would be very serious, and so we took our time. Unfortunately, as you can see, there was snow on the rocks because it had snowed the day before, and so we had to be also extremely careful. So this is the website. If you go on to Wikipedia and Google it, it'll tell you a little bit about the route. And as it says, first ascent climbed by Gros and Adler in 1973. So we did a little more climbing after this. This is another peak, not as high, that's closer to the coastline. So you can actually see the Nakvak fjord here as we are looking out to sea. So jumping ahead to 1975, this is, so that was the end of the kayak trip. Everybody, we all survived, no injuries at all. We got home safely, and we decided to go back 2 years later by sailboat. And so this was sailing in Labrador in 1975. You can see Virginia and I are here. Lizzie is the chief mate on the boat. Steve is taking this picture. Anyway, this is the boat from sailing up in the very northern part of Labrador. We had some interesting encounters with icebergs, as you can see here. We actually, obviously, this picture was taken from the dinghy. We set aside, we got off the boat, some of us did, to take this picture. This is one of the bays that we sailed into. We had been in the kayak previously. This particular bay has a little problem for the sailboat. You can't get across this. With kayaks, so there's no problem. We just carry them across. But we decided to come in here anyway because there was a storm brewing, and this is a very protected area. We're actually anchored temporarily to a beached chunk of rock, of ice here, small iceberg. But we did some more climbing, and this shows the ascent. Actually, that's Virginia right there, of a peak called Mount Tornarsok. It's not quite as high as d'Iberville or Mount Kalbik, and it's 5232 feet. I mentioned the names. It was interesting. I'll just flash back to that point. That peak, Mount Kalbik, was originally named, well, it had no name when we did it. We tried to name it after Grenfell, was a famous explorer up here, unsuccessfully. The Canadian Geographic Board didn't want to hear anything about a bunch of Americans naming a Canadian peak. But it turned out that the peak lies on the border between Quebec and Newfoundland, and the Quebecers named it after, or at least they thought they named it after a peak, after a person, a French explorer named d'Iberville, who has never been in this area, by the way. But as it turned out, it wasn't quite on the border, and it was 30 feet inside of Newfoundland, the actual highest point. So the Newfies renamed it Mount Kalbik after a famous Eskimo. But it's sort of known the same. So you can go on Wikipedia and either call it d'Iberville or Kalbik. It'll eventually get you to the same place. I should mention that, yeah, I think I mentioned once already that peak is the highest peak in Canada east of the Rockies. So, but it's also the most remote major peak in Canada, over 300 miles away from the nearest point of civilization. But anyway, so here's a summit view from Mount Torgersok, looking out towards the ocean, and this is Nakvak Fjord. I should mention that I didn't have a sailboat in 1973. I got this sailboat, and you'll see my pictures of it shortly, in 1975, but I named it after this fjord, Nakvak. So this is a picture looking down towards the Nakvak Fjord from the summit. And that little speck right there, if you can see it, is our sailboat. So we climbed over almost a vertical mile to get to the top of this peak. And this is a picture of me in 1973, standing on the summit. So here's another topographic map. Again, much more detailed than we had at the time, but this shows Mount Torgersok, 52 here, the Nakvak Fjord up here, and then Mount Kalbik / d'Iberville back down here. And this is another Google Earth image of the same area. There's something like 10 peaks over 5,000 feet up here in the Torngat. This whole range of mountains are called the Torngats, and it is now a national park. But there's still no way to get there easily. You either have to take a float plane or hire someone in a boat, or you could do what we did in kayak 250 miles up the coast. But it's still basically as isolated as it was when we did it in 1973. But it is a national park, and there are even routes that are you can go online and Google it, and you'll find description of various things you can do up here, including climbing Mount Kalbik. Here's another view. Here's a view of another peak that, again, was a first ascent. All the peaks we climbed up there were all first ascents. None of the Eskimos who lived up here ever would have considered doing something as crazy as climbing these peaks. And so it took some nutcases from the United States to begin it. Well, we climbed another peak in a place called Bear's Gut, and it's about 4,000 feet high. Now, my friend, our good friend, Chris Gertza, died in 1977 of a cancer, very tragically at a very young age. And after he died, we attempted to name this peak after him. And this was in the late 70s. So about 5 or 6 years ago, I actually never knew we were successful. And about 5 or 6 years ago, I looked at as I was preparing a talk, somewhat like I'm doing here, of this area. I looked on a map and I saw a peak called Mount Gertza, and amazing. So we were actually successful in naming this peak after him. And so it's a beautiful peak, as you can see. the view looking out to the ocean. And there's a website which describes Chris and his. He's quite an accomplished climber. He's done first ascents on Mount McKinley, not the first climb of mountain, but first ascent of the north face called the Wickersham Wall, and other major climbing events that he's, as well as here in Wyoming. He did a lot of climbing with some of the famous climbers in Wyoming as well. Okay, so that's Labrador, and so we're going to move on or move southwards to the island of Newfoundland, and talk a little about the geology of it, and then some of our you'll see some of the geology in our pictures, as well as some of our sailing adventures. So here's the assembled Newfoundland as it exists now, and it's broken into these various areas. I sort of touched on this a little earlier, but I'll talk a little bit about how it all got assembled. So the Humber region, which is on the peninsula, underneath, it has the base rock of the Canadian Shield, and it has that together with dunnage, and dunnage is pretty much what it means. It's all sedimentary rock from the bottom of the Iapetus Ocean that got pushed ashore and shoved over, in the case over this region, but actually created this area called the dunnage, which is, as I say, this middle region right here. Then this brown region, which they've lumped in this view graph, they've lumped with the dunnage area, is actually mostly granite that occurred about 400 million year old granite that occurred, that was in this island arc where there was some volcanics that occurred during this subduction event as the closure was happening of the Iapetus Ocean. And so that's largely volcanic granite. And then on the eastern side, this sliver called Gander and the Avalon are all fragments of Europe, and mostly Africa, of Morocco. So what happened was the Iapetus Ocean collapsed, went away. We had a collision of the continents, and then when the continent reopened, when the Atlantic reformed, starting 200 million years ago and beyond, these chunks stayed from Africa, stayed attached to North America. And I'll talk, and there's a major parallel to this on the European side. It's called Scotland. And I'll mention that in a bit again. Anyway, this western area is the northern end of the Appalachian Mountains, and in the Humber area, and they extend all the way down to the Blue Ridge Mountains in the southern United States. So this is a modern geological map of Newfoundland, the island, with the peninsula here. And a lot of this rock is exposed rock from the Canadian Shield. You can see this is Labrador over here. And so this is, in this case, it's not that old. This southern part of Labrador is only 1.8 billion year old gneiss, and that's similar gneiss over on this side as well. There's also various layers of sedimentary rocks along here. You can see in this middle area, in this in the dunnage area, there's all this red area, and that's all granite, and it's mixed in also with some limestone and other sedimentary rocks. And then you have this very different area over here on the east side, which is the conglomerates from ash and lava going back from Europe or Africa. And Okay, so anyway, so that's just a brief overview of the geology of Newfoundland. I want to so we're going to talk mostly now about the geology in this area down here, and that's in what's called the Gros Morne National Park. And I've already mentioned well, we'll talk some more about this as well. But one of the major interesting features of the Gros Morne Park is something called the tablelands, which is actually a region of the mantle rock that is now above sea level and is very impressive. And so this is a little cartoon showing that talks about the geology in the Gros Morne Park itself. The middle of the park is formed by Bond Bay, a deep, wide bay, and you have up here about 1 billion or year older gneiss, which on top of the long range mountains, again, the northern end of the Appalachians, a fault that runs through here. And on the other side of that fault is largely sedimentary rock, much younger, 400 and some million year old sedimentary rock. And this area called the Tablelands is all 500 million year old peridotite. It's mantle rock that normally is 20 miles below the surface, but during the collision that occurred during parts of the orogeny, the tectonic orogeny, it was squeezed up and is now forms this tableland in the Gros Morne Park, and it's probably the largest area of peridotite that's above sea level in the world. So this is the same map, but I've just labeled differently. I'm going to show you pictures of some of these areas. So we're going to show you a picture of Western Brook Pond here shortly. The Gros Morne Mountain is here. Should talk about that. There's something called Norris Point. There'll be a picture of that shortly. Green gardens, some volcanics there, and then the tablelands that I just talked about, this peridotite. So here's Western Brook Pond, at least after you've managed to get up to the top. It's about, this is maybe the most dramatic and iconic part of the Gros Morne National Park, but there's no trail to here. There's no easy way to get to this point. You have to actually hire a boat to take you down the pond. Now, I should mention something about the pond. This once was at sea level. It's now 100 feet above sea level, because what happened is this bay was heavily glaciated 10,000 years ago during the last glaciation. When the ice melted, the land rebounded, and it essentially cut this bay off, which was a bay in the ocean, and created what's now called a pond, the Western Brook Pond. So it is not seawater. It might still be somewhat brackish. It probably isn't. It's probably pretty fresh by now. But anyway, so you have to get a guide to take you by boat to here, and then you need the same guide to navigate all the way up here, because it's a very difficult route. There's no established trail. And it's the worst part of it is that it's infested with the world's worst swarms of black flies that I've ever encountered. And it was pretty ugly getting up here. But finally, when we were able to climb that 2,000 feet to get up here, we were out now in a breeze, and the flies were much better. Anyway, so I'm going to come back, and we're going to talk some more about the Western Brook Pond in a bit. But this is, I mentioned Norris Point. This is a folding of the shale, of layers of limestone over shale that occurred during this tectonic orogeny, this collapse of when the Iapetus Ocean collapsed. This is hiking on this peridotite tableland rock. As I mentioned, this is this is probably the largest area of exposed peridotite in the world. So this is one of the major features of Gros Morne Park. In fact, as I didn't really highlight it, but the park itself is really a wonderland of geology. So this is just another view of the tablelands. Its peridotite is ultramafic. It contains less than 45% silica and has a fair amount of iron and manganese in the form of olivine in it. There's areas of it where it's been metamorphosed, which is quite interesting, and it creates this rock called serpentite, which is, you can see what it is. It looks like almost a fish scale, and it's what happens to the peridotite when it's exposed to heat and flowing water, and it has this green, which is probably from the olivine that's in it's made up from. And you can also see these interesting patterns, these crystalline patterns that look like snake-like patterns in the rock as well. So this is a view from the tablelands looking over Bon Bay. Okay, so now going back and to Western Brook Pond, I mentioned how it was formed. This is just a reflection, obviously, while we were on a boat trip going to the end of it. The rock is on the top is mostly 1.5 billion year old gneiss and granite. From the orogeny when Rodinia was formed. This is a view looking down Western Brook Pond from the boat. And this is the same view I showed you in a bit. But we, while we were up there, we did we walked a little bit more and on this beautiful open rock. And then we unfortunately had to go back down through the swarm of black flies to get to our boat. But anyway, we made it. And overall, it was, we had a beautiful day for this. We were very fortunate. On the way down, there was this nice waterfall. Okay, so then the following day, we climbed Gros Morne Peak. Gros Morne Peak itself is mostly sedimentary rock, 500 million year old sedimentary rock, largely from the bottom of the Iapetus Ocean that was scraped up during the Acadian orogeny. And on top of it is Cambrian quartzite. And so we'll, and there's just another view of the geology map. The mountain, just to remind you, is up here. Western Brook Pond is here. Tablelands here. Yeah, we're also going to, I'm going to show you some pictures of some volcanics that are down here at Green Gardens. And the last thing we'll see is something called Cow Head up here, where this limestone. So this is a view looking from pretty much the summit of Gros Morne Peak, about 3,000 feet. And looking down at something called 10 Mile Lake. And here's Virginia on this quartz cap over the shale and limestone. And so now we're down at sea level at Green Gardens, where we have the intrusive rock, basalt, basalt, as well as some pillow lava that was emitted underwater and formed these nice little pillows. Also, we have some quartz intrusion into the gabbro. And then at Cow Head, you have this interesting limestone formation that is has been totally tipped up by the Acadian orogeny. So it's a very, very interesting example of all the geologic forces at work in this area. So now I'm going to make we're going to jump across the Atlantic and just mention something I mentioned earlier, that this orogeny, this event, this closing of the Iapetus Ocean and the collision of the continents had effects on both sides of what is now the Atlantic. And one of the most notable features that occurred on the European side, they called it, it was called the tectonic orogeny on the on our side, the American side. It's called the Caledonian orogeny on the European side. And it's a mountain building orogeny, just like it is on our side of the ocean. But here's what actually occurred: a cartoon showing the narrowing and collapse of the Iapetus Ocean. Here are the what are going to become parts of Northern Ireland and Scotland. Here's Southern Ireland and England. And as time goes on and the ocean collapses, you get a merging, and so you get this area merging together. And then when the current Atlantic formed, guess what happened? These chunks stuck on top of England and Ireland, and when they separated, so we have a chunk of North America that's now part of the European continent, and it's called Scotland. And of course, we on the field trip that we did in 2015, which this next picture is taken from that, you can see the amazing geology that's evident there due to the same event that occurred. And here, just a flashback to those who are on this trip. This is a 3 billion year old gneiss they call it Lewisinian gneiss after the island of Lewis, on top of 550 million year old quartzite. And then this is Lewisinian gneiss here. So this is a unconformity, a 2.5 billion year unconformity of this gneiss of the quartzite on top. And then you have this thrusting of that occurred with the same layer of gneiss from something like 20 miles further away, slid on top of the quartzite. So you form this sandwich of gneiss, quartzite, gneiss. Anyway, that's I just thought I would mention that just to highlight the fact that there was an event that occurred that parallels the event on this side. I'm going to have to move a little more quickly, and most of the geology is over now. I'm going to just give you a brief set of pictures of our sailing trips, our 18 sailing trips that we made. This was our very first trip. I didn't even have the name of the boat on it yet, but we hauled the boat all the way from Niskayuna, Schenectady, New York to Cape Breton, 1,100 miles. This was our, we were on the coast of Cape Breton, at a town called Ingonish, and we were going to make our first crossing across Cabot Strait. So this is Cape Breton, this is Newfoundland. So we did this crossing overnight and arrived over here in the day. The first 6 times we did this trip, we crossed Cabot Strait, and it was never my favorite part of the trip because this is a nasty batch of water. It can be very nasty, particularly coming back, because you have to go into the prevailing southwesterlies to get over here on the way back. And that's never a lot of fun. Plus, this is a fog factory. The whole south coast of Newfoundland is a lee shore. Warm southerly winds come on, hit this cold water, and you create fog. And so navigating the strait as well as along the coast is often done in the fog. But we, in over 18 trips, we explored this area and got to know a lot of friendly, nice people in various villages on the coast. And we explored the whole area many, many times. Some of our favorites are, I'll just briefly show you. Geology map, a lot of granite in this section where we spent most of our time. This was our very first arrival on the south coast after I had worked out the scheme of how to get here by trailer and having the boat launched in Cape Breton and sailing across Cabot Strait, and with a baby that was about 1 year old at the time. And here we are at a place that has the name of Île Morte, but in spite of its name, it's quite a beautiful spot. As you go east, you get into the area that's largely granite. This was the town, one of the towns on the south coast. This is where this is the last town on the south coast that had the road to it from the west. And there, after you leave Rose Blanche and go east, there's no more road until you get all the way across the entire south coast, and you're in the St. John's area. And then there are roads coming west from St. John's for a little ways. This is one of the outports. There's no roads along the south coast, but there are towns, and they're all accessible only by water. So one of the areas that we enjoyed was this central area. It's called on the coast, called a little town of Grand Brit. We got to know the people here very well. If you look at this chart, you'll see this is a British Admiralty chart. This chart was, these charts on the south coast, what we had, these are the charts we had available. They were done by the British in the 1880s, 70s and 80s. And they had some significant longitude errors, like as much as a mile. But over the years, I learned where everything was, and gradually the technology got better, and I went from dead reckoning to various things like Loran A and then C and then finally GPS. So I worked out all the locations of all this stuff and knew how to do it. This is the village of Grand Brit that we had some very close friends, and our children, we came back here year after year, and our children began to become friends with some of the children here. And we became friends with their parents. And this town is, the name is Great Noise, excuse me, is named after the waterfall. Unfortunately, this town isn't occupied anymore. The fishing on the south coast of Newfoundland is pretty much off. Is over. It's a moratorium because the cod, it's been overfished, and the Canadian government, so people can't make a living here anymore. These villages have been abandoned. The government has essentially paid for the people to leave and move to other locations. And this is just some of the terrain around there. This is one of the beautiful bays that are just right next to Grand Brit. It's just a view. We spent many years exploring this area. This is the next area along the coast near a town called Burgeau, which is actually a fairly large town, and it does have a road to it, but doesn't go along the coast. It comes down from the north. And the last 6 times we went here, we actually took the boat all the way here by road, because they finally paved. It's a 100-mile road from the Trans-Canada Highway. And once they paved it, we actually came here because we could launch the boat here, because they have services that are meant for the fishermen, but they were happy to launch us as well. And beautiful country here. Some of the this is actually a provincial park. It's called the Sandbanks, with all these beautiful sand dunes and islands. We did fish before the before the moratorium on cod fishing. We were fishermen, and we caught lots of cod, which was wonderful. Here's a picture of Virginia and I in 1981 in our cabin on our tiny little boat. We lived on this boat for 3 weeks plus when we were on the coast, and in all forms of nasty weather, nice weather, fog, rains, everything. This is one of the islands off the coast called Ramia. Then one of the last areas that we probably one of our favorites were the high bay area, where these deep bays go in 6 or 7 miles from the coast. The areas on top are about 1,500 feet above sea level, mostly granite with some sedimentary areas. This is probably our favorite spot. It was called Dead Man's Cove in a Lahoon Bay, and you can see the beautiful rock that forms these bays. We climbed many times. We've climbed up this particular hill to get up to the tableland on top, 1,500 feet or so above sea level. It's a picture of our boat looking down there. Pitcher plant, which is actually the flower, the Newfoundland flower, such as it is, and some nice blueberries. This is how we did our laundry in freshwater ponds. This is one of the villages that's in the Lagoon Bay, taken in 1950, but it was abandoned shortly after then. And this is my picture of it in 2005, our last trip there. And you can see almost everything is gone. That's just, it was a color picture. You can see Dead Man's Cove is just on the other side. It's right over here is Dead Man's Cove. Beautiful waterfall that we were walking up. Other bays further along, Bay de View. It's a picture of our boat sailing down the coast. Another bay called Averon Bay, which we visited many times. A beautiful wishbone type of waterfall here. Here's a picture from the water level looking up at that waterfall. We've had some horrendous blows in here, by the way. Every once in a while, you'll get in here and you'll get winds that'll come down this cliff. And one time it blew almost hurricane force winds. Fortunately, my anchor held and we survived, but it can be pretty hairy up here at times. This is a village that still exists, one of the few, maybe the only outport on the south coast of Newfoundland that still exists. This was, it's called Francois, which is at the end of one of these bays. We had arrived here on a day where we left about 3 hours before, entered out into the pea soup fog, and I managed to navigate my way along the coast with zero visibility, find this bay, and then came in. The people I was with were blown away that I somehow managed to do this. But by then, this was 78, I had developed enough techniques and navigation skills to be able to pull this off. Here's what we looked like in 1978 when we arrived. We were quite the scene as for the locals. Every time we went to one of these places, we were definitely subject of a lot of curiosity. This is the village of Francois on a nice day, and it's at the end of this precipitous bay. Lots of beautiful hiking that's involved there. This is the last bay that I'm going to talk about. This is Roncounter Bay. Amazing rock formations here. This beautiful church. This bay, this town was abandoned even before we ever got there. So some people still had houses they used for the weekend, but the church was there and it managed to stay standing until 1987. And this is in 1982 when our daughter, it was always a favorite thing for us to do, to come here and see every year, did this church still survive? And unfortunately in 1987, the locals had taken so much wood from it that it blew down one winter. Beautiful musseling. Here's on the left is musseling in 1985, catching mussels. And here's musseling in 1994. Our son was about the same age as our daughter in 1994. I think the bucket is the same bucket that we were using in 1985 by the looks of it. And we did lots of beautiful hikes. There's our boat, incredible rock formations here. Major rock climbing opportunities if you were into that. At the time, I was not. And this is the very end. So this is Saint Pierre. We visited in 82 and 94. I'm showing this largely to show the difference in the geology, because these islands, which are French islands, were quite amazingly different from the South Coast. When we first got there in 82, there actually were places where patisseries and French restaurants you could go to. Whereas on the South Coast, you only had stores which had canned food at that time, nothing fresh. The economy was mostly fishing, but tourism. So because the French Canadians loved to come to a piece of real France, and so they were here. So a picture of Saint Pierre during the sailing era. Here's a picture of Saint Pierre during Prohibition. These bottles are booze. A lot of booze came into the United States from Saint Pierre. If you look at this building in the background, this was in the 20s, obviously. This is my picture taken in '82. It's the same buildings. It's just they're not quite as quaint looking as they were in that era. This is the larger island, Miquelon, which doesn't have as large a town, but it's still an interesting place to explore. And that's it. So at the end of the talk, I'll if there are any questions, it's pretty much a whirlwind tour of Eastern Canada, and hopefully imparting some information about the geology of that area, which is quite fascinating. I think, frankly, a lot more interesting than the geology of the lower East Coast of the United States. But anyway.
There's Mike. Any questions for Mike? You can either unmute yourself and ask questions, or just a loud round of applause, of course. But Mike, I just got to ask, that first trip, whose crazy idea was it? One, and number two, how did you console your wife?
Yeah, well, it was Chris Gertz's idea. My friend Chris, it was his idea to do that trip up the coast, and it was not his idea to do the climbing. We were intending to go across and cross to the other Ungava Bay side, but as I mentioned in the talk, there wasn't enough water in that river at the location that we intersected it to do it. But it was his idea. I was actually at the time quite pleased with that outcome. However, I was much more interested in the climbing of that area than I was in crossing the peninsula. And of course, we ended up with this fairly major summit that is to this day. I mean, it's not often you can climb the highest peak in an area that's significant, and so that's one of my feathers in my cap from those days, having accomplished that.
And let's see, you were gone what, 7 weeks? Did you say?
No, it was, all things considered, it was probably, by the time we actually got back, it was over 6 weeks. Yeah, something like that.
And how did you console Virginia?
Well, she was so hopeful I would return. It was it was I think she was hopeful I would return anyway, but she seemed pleased when we got back. We were starving though at the time. I had lost quite a bit of weight. I remember going into a grocery store and buying a 6-pack of Snicker bars and eating all of them in one sitting. It was, when we were up there, we were short of food, and particularly when we were hiking, we would ration our food. I mean, we had each day we had a bag of food for a day, so we couldn't. We had a few extra days, so every once in a while we treated ourselves to an extra day. But Chris was amazing because he was the only one that wasn't short in rations. He didn't get any more food than the rest of us, but his body metabolism was so much more efficient that he had plenty of food. In fact, he would not eat all the candy that was every day we had our allotment of candy, of Snicker bars and raisins and what have you, and Tootsie Rolls. And in fact, we would joke about it. Is it better to just chomp down the Tootsie Roll or suck it and make it last as long? And the other thing, needless to say, money didn't count up there. There was nowhere to get any more food other than catching fish. And we would run short. But Chris had this bag of extra food, and mainly candy. And I hated raisins. Even starving, I would have a hard time eating raisins to keep my lunch down because I just couldn't stand the taste. So he kept the bottom from the raisin market from falling through completely. He was willing to trade raisins for Snicker bars or Hershey bars, and so I'll never forget that experience of being up there for weeks now, short of food and doing all of this and dreaming of what it would be like when we finally got out back to civilization.
So Mike, there's a couple other questions from the audience. The geologic maps look very detailed, way
Yes.
more than navigation maps. How and why is that?
Yeah, that's a good question. The navigation maps have gotten better, by the way. So the last trip we made in 2005, we actually had newer charts. And but it is interesting though, because now it is true that creating a navigational chart is not easy, but creating a geological chart isn't easy either. But a navigation chart means you actually had to go out there and sound the water, and that is a very difficult, time-consuming, expensive process. And it's very interesting when you look at Labrador. Now, I was showing you only charts of Newfoundland, but the Labrador charts were even more sketchy. And all there was when we were in the sailboat, we didn't need charts, depths for kayaks, but when we were in the sailboat, all there was a line, one single line of depths that ran up the Labrador coast. And then there were areas where they simply draw squiggles across the chart and said non-reconcilable. That basically the chart, they had it coming from two different directions, and it didn't really mesh up correctly. And so they simply just threw up their hands and say non-reconcilable. Well, eventually, there just isn't a lot of commerce up there in Labrador, and even in Newfoundland. And it took some time before the Canadian government decided to actually launch their own efforts to do the charting of creating new nautical charts. Now, one of the reasons for the geology, though, is commerce, because there are minerals in Newfoundland. And so just like everywhere else, I think the geology maps got formed, the details, because of people searching for minerals. And there's even gold mining done along the south coast of Newfoundland. So I think that's part of the answer, is that of the oil, oil would be mostly offshore up there, but search for other minerals and was probably the reason that the geology charts are as detailed as they are.
And the next question also concerns the geologic reconstructions and the cartoons. What was your source on those?
Yeah, those are most of that is all done by the Canadian government, and if you go online and you can find these most of those charts and the cartoons, and it's a high level. What I was giving you here obviously was a high level view of the geology. There's, needless to say, a lot more detail underlying all of that, but that high level view. There are Canadian government websites that have all of that information on them.
And I think this might be the last question. You did a night crossing. Why did you do it at night, and how long did it take you?
Yeah, every crossing that we did across Cabot Strait were always night crossings. And why? Because you wanted to arrive on the shore, the opposite shore, during daylight. And so the easiest way to do it was to do it at night. You left sometime during the afternoon or whatever, depending on how far you were going to go, and you would then the crossings tended to be somewhere between 15 and 25 hours. And so, well, the 25 hours, it would be a full day, but 15 hours would be the shortest, the shortest crossing. And that would, so if you left in the afternoon, you'd be there the following morning in daylight. And you don't want to come onto a shoreline from offshore at nighttime, particularly that shoreline where there are no navigational aids almost. It's devoid. Even in 2005, there really were no navigational aids along that entire coast. That each of the little towns, like Burjo had some buoys because it was a major town, but like Grand Brit had one buoy off of it that just sort of announced that you were arriving at a town, and that was it. Along the shoreline between these towns, there was no navigational aids at all.
Yeah. And the other question concerns when you're backpacking and hiking, I'm assuming you carried some kind of fuel. There's no wood up there, so you weren't making a fire to cook with.
No, we carried, it was all gasoline, it was all white gas in those days. Yeah. They were Svea stoves, you probably have seen them, the old Svea stove kit that you had a Svea stove nested in with a set of pots. And we had several of those, and that's what we did.
And what kind of wildlife did you see, not counting fish?
Yeah, right. There are caribou up there in the summer, in Newfoundland in particular, caribou. But probably the most significant wildlife we saw when we were in Labrador, and this was on the 1975 sailing trip, was a polar bear. And Virginia has an incredible story to tell about the polar bear. But the short story is we were on an island. Actually, the name of it was called Mainmont Island. And she and Lizzie were just exploring and looking at the flowers and what have you. And they were both bent over looking at some flowers. And Virginia raises her head and looks up, and she finds a polar bear 20 feet away, fully erect, standing in front of her. And Lizzie is very excitable. And so Virginia says, in my most authoritative school marm voice, I said, Lizzie, there is a polar bear in front of us, and we need to quietly, very quietly stand up and get link arms to try to make ourselves look bigger and slowly back away from this bear. And they did exactly that. And the bear just fortunately didn't do anything. It just stood there. And they just backed away on the other side. They got over the side of a hill, and they were out of sight of the bear, and they took off. Now, I didn't see this particular encounter. I did see the bear, though. The following day, we had a fishing net set out, and the bear attacked the fishing net to get at the fish that were in the fishing net. And we all got a sight of the bear. We did carry a rifle, a high-powered rifle, for that reason, as well as just in case we thought maybe about hunting briefly, but anyway, the rifle was never fired. The bear was never a threat, but it was certainly the most significant wildlife. But we also saw a lot of black bear up in Labrador too. We probably ran across quite a few black bear over the various time we were up there. We also saw wild dogs, feral dogs that were probably once belonged to people up there that they just let them go wild, and they were a threat also. So we had to be very careful about that as well.
Well, Mike, I don't think there are any other questions, so I want to thank you on behalf of all of us for yet another excellent talk. I know you're into double digits at this point for GJ talks.
I actually added it up once, Mike. I think I've actually done over 20.
Oh, okay. Way over double digits then. And I think 21's coming up next year. So
And by the way, I wouldn't do it if I didn't enjoy it either, obviously. So, you know.
right. But amazing photographs, very good geologic overview. And, you know, thank you from all of us again for another wonderful and entertaining talk. And we look forward to number 21 or 22, whatever it will be.
Okay. Yeah. Yeah. I haven't. Yeah. It's in that general area. Now that includes the luncheon talks up at the museum and everything. But anyway, that's the total more or less.
Right. Well,
Yeah,
lunch
well,
talk.
I enjoy doing it, and I enjoyed doing this talk a lot, and you can imagine why. Because for me, it's just it's a trip down memory lane of going back into that time when we were up there in Labrador, but all those years with our children grew up sailing in Newfoundland, and both of them. So it was we didn't go to Disney World. We didn't take them to Disney. We took them to Newfoundland, and both my
Right.
daughter reminded us of that on a number of occasions.
Right. Well, it was also wonderful to see pictures of you in Virginia from 40 something years ago as well. So
yeah.
thank you again. And we'll look forward to the next talk. So
Okay, very good. Thanks a
good
lot.
night, everyone.